This is the Unit 3 review 3.03 on inequalities and equations. So this unit review, we're going to cover two standards, AR 2.1 and 2.2. We're going to work with inequalities and two-step equations today. So at this time, you can go ahead and either open up your Unit 3 test, or if you're just preparing, just keep in mind that this is for the 3.03 unit test, which is due on 10/27. So the first thing we're going to go over when we're preparing for this test is inverse operations. Now, inverse operations are probably the most important thing or concept to remember from this unit because we use them in both two-step and in one-step inequalities and equations. So an inverse operation is simply the opposite. So when we're working to isolate our variables, we always want to make sure that we are removing all of the numbers and operations surrounding that variable. And in order to do that, we need to use those inverse operations. So for example, if something is being added, in order to cancel out that addition problem, we would need to use the inverse, which is subtraction. If something is being subtracted, in order to cancel that out, that negative value, we would need to add in the value back in order to cancel it. The inverse of multiplication is division, and the inverse of division is multiplication. So we're going to look at how that applies to solving inequalities. So I have 4 different examples of inequalities that we are going to solve on the screen. So as always, make sure you're taking notes, following along, and if you have any questions, of course, you can reach out. So let's go ahead and start with the first box. It's got a green outline, and we have 14 is greater than or equal to -4 plus z. So again, keeping those same concepts in mind, our goal always is to isolate our variable. So in order to do that, we need to look at what's attached. Well, here we have an addition sign, so we know that there's adding. But what's being added to z? Well, -4 is being added. So we need to undo that -4. Keep that goal in mind. The goal is to isolate the variable. So everything else has to be removed. So we're going to add 4. Again, keeping the balance, add 4 to both sides. Now we can go ahead and bring everything down. On the left side, we have 14 plus 4, which is 18. We bring down our sign, and we bring down our variable, which is now isolated. So this is an example of solving a one-step inequality. The variable is now isolated. Now, the final thing that I would do on this problem is I would go ahead and flip everything so that we lead with the variable. It's not a mandatory step, but it is a cleaner answer. You may sometimes have an answer or the variable on the opposite side. So it's good to flip it at the end so you lead with the variable. The next one we're going to review is in this pink box over here. And so again, we look at what is the impact on the variable. So here's our variable. If our goal is to isolate the variable, we need to figure out how to get rid of +7. So in order to get rid of +7, we subtract 7 from both sides. G is less than. We have 50 minus 7, which is 43. And as always, you can use your calculator on these. So if you feel like you're not sure when you're doing that computation step, if you want to check your work, go for it, use your calculator. But often these computation steps will not be too hard. But there will be your final answer. Again, this is just one step. We only need to do one thing in order to isolate our variable. And now we have our solution, which is G is less than 43. Again, just a quick review with inequalities. The variable represents an unknown value. So what this is saying is G could be replaced with any number that is smaller than 43, and the equation would still be true. So we're going to go ahead and move to the next slide. And we're going to continue with using the inverse operations to solve these one-step inequalities. But this time you're going to notice that our operations are different. So on the previous slide, we focused on addition and subtraction. On this slide, we are focusing on inversing if there's any division or multiplication. So I'm going to go ahead and show you this first example. First example is x is being divided by 4, which is less than or equal to 5. So again, we have to look at the impact on the variable. If we want to get the variable by itself, we have to undo whatever is happening. So in this situation, x is being divided by 4. So we have to look at our inverse table up in the corner here. What is the opposite of dividing? Well, the opposite of dividing by 4 would be multiplying by 4. So I multiply both sides by 4. X is less than or equal to, and I have 5 times 4, which is 20. So again, it's a one-step inequality. It only takes one step to isolate our variable and find our solution. Next, we're going to look at our second box. And again, same thing over and over again. We look at our variable and we have to look at what is the impact on our variable. So this variable is being multiplied by 2 over 5. So in order to undo multiplication, we are going to divide. But since it's a fraction, we know that using keep, change, flip, that's the same thing as multiplying by the reciprocal. So in order to cancel out 2 over 5, we're going to multiply both sides by 5 over 2. This cancels out that fraction. We're left with x and our symbol, and then we have a multiplication problem over here. We have 5 over 2 times negative 20, so that is going to be negative, and again, if you need to use your calculator, you can, negative 100 over 2, which simplifies to negative 50. And then again, because this is backwards, we can rewrite this. X is less than negative 50. So on those 4 examples that we just went over, if you noticed, every single one, I asked myself the same question. How do I isolate my variable? So what's happening to it and how do I undo that computation? So if something's being added to it, you subtract. If something's being subtracted, you add. Multiply, you divide, divide, you multiply. So these 4 questions will really help you with questions 1, 7, 8, and 10 on your unit test. So as you're working through that test, you can come back to these slides again between the last page we did and this page, questions 1, 7, 8, and 10, and you can see those listed on the bottom of this video as well. And now let's go ahead and move on to the next concept. This is going to help you with question 6 on your test. There is one little loophole when it comes to solving inequalities. The steps that we just did are normally the steps that we take. However, if we multiply or divide by a negative number, it does create a small change in our solution. So what happens when you multiply or divide by a negative number? Well, we know from unit 1 of this year that if you have a positive number, like say 6, and you multiply that by a positive number, well, your answer is still positive. However, if you have a positive number and you multiply that by a negative number, then your solution will become a negative. So the issue is when we multiply or divide by a negative number, it impacts the outcome of the solution. So in order to counteract that impact from multiplying or dividing by a negative value, we need to flip the sign. So again, this is only a situation that occurs when you have to multiply or divide by a negative number. So let's look at the 2 examples, and we have 2 different samples. One is going to be when you do flip the sign, and the other will be a very similar example when you do not flip the inequality sign. So I have negative 8 is greater than or equal to negative 32. I'm looking at the impact on my variable. It's being multiplied by negative 8. In order to undo multiplying by negative 8, I divide by negative 8 on both sides. So The reason why here we would flip the inequality sign is because in order to isolate x, I did have to multiply or divide by that negative value. So x, I flip my sign, and that flip of the sign is just that. It's just the reversal image. So instead of being greater than, it's now less than. And I have negative 32 divided by negative 8, which would be a positive 4. So that's a situation where you would flip the inequality sign. Let's look at a situation where you wouldn't. So again, just because there's a negative in the expression or the inequality does not mean that you automatically flip it. It's very specific, only when multiplying or dividing by a negative number. So in order to isolate my x here, I'm going to change my color. I need to divide by 8. So let's look at what I just divided by. Did I have to multiply or divide by a negative value? No, I didn't. And that is different from in the first example where in order to isolate x, I did have to divide by 8. In this situation, I divided by a positive to cancel out and to isolate my variable. So I do not have to flip the inequality sign. So I know that's a lot of information. The rule simply comes down to when you multiply or divide by a negative value, your inequality symbol does flip. So you can use this page to help you with question number 6 on your 3.03 unit test. And we're going to move on to graphing inequalities. So inequalities graphing is actually my favorite part of this unit. Graphing inequalities is simply the visual representation of what the inequality is. And so we can review this box here for a second that has some great information about those inequalities. When graphing inequalities, there's two main things we need to worry about. We need to worry about what kind of dot we're going to use. So we have two options. We either have an open dot or a closed, or you might also hear the term filled in dot. So obviously the difference is one is an empty circle and one is scribbled or colored in. Now, when would we use each of these symbols? Well, we're going to use the open dot if we use the inequality symbols that are less than or greater than. Comparatively, we're going to use the closed circle or closed dot when we use the symbols less than or equal to or greater than or equal to. So the only difference between these two dots is that equal bar at the bottom of the symbol. So again, no equal bar, open dot, equal bar, that dot is filled in. And really all that means is that the inequality line includes that number or does not include that number on the line. The second thing we need to worry about is the direction of our arrow. The direction of our arrow, which is great, is just going to match the direction of our symbol. So I'm going to go ahead and start graphing. The first one that we have is x is less than or equal to 4. So I'm going to find 4 on my number line, and I am going to do a closed circle. Again, because I have the symbol that has the line underneath it, going back to my graphic over here, if it has that equal sign, it does include the number. So I color in my circle. And then if x is a number that's less than or equal to 4, that means my number line would include any of these values. So you can see that my line is going towards the negative, towards the smaller numbers, because x is a number less than or equal to 4. I'm going to change my color as I move on to the next one. X is greater than negative 8. So again, I find the number on the number line. In this case, I'm going to use an open circle because my symbol did not have the line underneath it. So it does not include the number 8, but x is a number greater than 8. So I'm going to go towards the increased values, and that would be my number line. So again, you're really only looking at a few things. Plot the number from the inequality, and then you have your symbol. You just need to decide open or close based on equal to or not, and then the direction of your line. Last one, x is greater than or equal to 1. This has a line underneath it, so this will be a filled in circle. And then x is a number that's greater than 1, so obviously I'm going to go towards the increased values. So this can help you with question number 9 on your Unit 3 test. Biggest thing to keep in mind is those circles. Make sure that you know the difference between that open and the closed circle. Next, we're going to talk about writing the inequality from the number line. So this is the opposite of the slide that we just did. In this situation, we're given the number line and we have to write the inequality. So we keep the same concepts in mind. First, we write our variable and our letter, or sorry, our variable and our number. So the number is where the dot is. And the next thing we want to do, just like we did on the last slide, is we want to figure out what does the open versus closed circle mean? Well, closed circle, that means that my symbol is going to have an equal sign under it. And then my numbers are pointing in this direction. So I know that x is going to be a number that is greater than or equal to 7. Next one is in my second box here. Again, I start with my variable of x, and then I put the number of the dot, or where the point is plotted. I have an open circle here, so that means I know that I'm using a symbol that does not have the equal bar under. And this is going towards smaller numbers. So I know that x is going to be a value smaller than 4. X is less than 4. And finally, the last one, again, we start with our x, then we plot our number. And again, I have an open circle and it is decreasing, so I know that x is going to be a number less than -85. So use this page to help you with question number 2 on your Unit 3 test. Again, just get super comfortable with those circles, what they mean, and then the direction of those arrows. The next thing we're going to look at here is solving two-step equations. So two-step equations is going to go back to what we talked about with the one-step inequalities. We are using those inverse operations. So those inverse operations do not change. We are still using whatever is the opposite. When we're solving these two-step equations, in order to solve our inverse operations, we're going to look for the two items because it's a two-step equation. There's going to be two different items that we need to remove in order to isolate our variable. So in this situation, the first thing that we can see is this -3. In order to cancel out -3, I'm going to add 3 to both sides. This leaves me with 0.2x equals, and then I have 7 plus 3 is 10. The next thing that I need to do is figure out what's the next thing that's impacting my variable. And I have this 0.2x, that means it's being multiplied. So in order to undo that, I am going to divide both sides by 0.2 in order to cancel that out. Now my x is isolated. I have 10 divided by 0.2, which is 50. So again, solving those two-step equations, I am taking whatever addition or subtraction there is first, and I'm getting rid of those, and then I'm worrying about my multiplication or division, and then finally my x is isolated. Going on to the second example, same steps, same process. Goal is isolating the variable. That goal has not changed in this entire unit. The first thing that I notice I need to get rid of is this +5. So what gets rid of +5? Well, subtracting 5 from both sides. This would leave us with x divided by 2 equals 17 minus 5 is 12. Finally, I'm down to one more step. My goal is still isolating the variable. X is being divided by 2. In order to get rid of it, I need to multiply both sides by 2. And this leaves me with x equals, I have 12 times 2 over here, x equals 24. So I just did two different examples of solving two-step equations. This will help you with questions 3 and 4 on your Unit 3 test, questions 3 and 4. And finally, the last thing we're going to talk about is another two-step equation example. However, this one looks a little bit different because we can't do the multiplication or we can't do the addition subtraction step first. So, and the reason why we can't is because we call it like being blocked or being, kind of hidden within these parentheses. So because our addition problem is kind of stuck under the parentheses, we need to remove the parentheses first. And the only way to do that is to get rid of this multiplication problem that we have. So 3 is multiplying x plus 5. So in order to get rid of multiplication, we're going to divide. Dividing both sides by 3, and you'll notice what happens when you divide this by 3, now we're just left with x plus 5 on this side. So now we are able to get down to just that one step. 15 divided by 3 equals 5. So now we're down to just that one step equation. I'm subtracting 5 from both sides. And this leaves me with x equals, this cancels out, and 5 minus 5 also cancels out, x equals 0. So use this slide to help you specifically with question number 5 on the Unit 3 test. And this is actually the end of our review. So in this review, I covered the information that will help you with all 10 questions. Remember, every slide did show what question it will help you on. That way, when you're going back and forth, you can see exactly what question and which part of the video you need to review if you're having trouble. Don't forget that there is a notes deck posted for this lesson as well for your review. You can review this video. If you need anything, please feel free to reach out to me or any of your other teachers or your math teacher in order to get extra help. So I hope this video helped, and thank you for watching.